Okay, so first off, does anybody remember the difference between a block and a strata? And you can either unmute yourself or type directly into the chat box. Pull up the chat here if we've got anybody. So anybody for block versus strata? Okay, so unless I'm missing it, not seeing anything coming into the chat box, I assume maybe you've forgotten, but blocks are specifically for experiments. And then strata would be for a survey only. So in this case, we're doing an experiment, and it says that here because we're randomly assigning subjects to 2 different treatments, and that would be the type of shoe, either A or B. So here, that's why they say blocking and not strata. So keyword for A is blocking. So it wants a statistical advantage. So when you're talking about a statistical advantage, they want keywords like confounding variables, maybe reducing some variation, keywords like treatment group, response variable, anything like that is what they mean by a statistical advantage. So can anybody recall an advantage of blocking? Ah, here we've got some chat going here. There we go. Okay, they just must have not been coming through before. So yes, we've got some excellent responses here. We've got reduces variability, confounding variables, guaranteed to sample members from each group. Okay, yes, those are all very good things, okay? And I like how we're doing confounding variables and variability and saying reduce instead of eliminating, using that language. So for this one here, it's actually going to be the variability for the blocks. Reducing confounding variables, that's more of randomly assigning to treatment groups, okay? So the blocking goes hand in hand with that variability, okay? So the first thing we want to say here is it accounts for variability and then it's going to be the response variable which we're measuring, which you could either say is the running time or running speed, something like that. So it counts for variability, and I'll just say running time. Now, what you want to do is always give the context. So you want to give a real life example that makes sense, just to show the graders that you understand. So for instance, we could say that the professional runners likely have, now be careful, don't say a higher one, okay? You have to say professional runners likely have a lower run time compared to, what was the other group called? Okay, just recreational runners. Yeah, we can put that. Okay, so there's the context. So what that means is the variation in time would be reduced by each block, right? So runtime variation, you could say, would be reduced in each block, okay? If, of course, we block based off of runner type. So far I've answered the question, and I've done so in context with an example. And then it's always important to wrap it up with why this matters or why this is important for researchers. So why do you want to account for variation? Well, it makes it easier to detect a difference. Because if you have variation and a difference going on, it's going to be really hard to determine, well, what was a difference in just runner type and what was a difference based off of the shoe. Okay, so you can end with saying blocking makes it easier to detect any difference based on shoe type. And these are the type of free response questions where you don't want to be just answering it in a sentence. You really have to be thorough. You've got to get the real life context. You've got to use those keywords such as variability. Just be careful with confounding variable, because a confounding variable would be better addressed with randomization, like an SRS. Okay, this is not really a confounding variable. This is more of just that natural variation. Okay, because a professional runner is probably going to be more experienced. So we want to make sure that we're getting an equal number of runners in each treatment group, and that is done so with blocking. And you could comment on that as well. You know, you could say that this is guaranteeing to sample both professional runners, recreational, something like that. Does anybody have any questions on part A? See if we've got the chat bot works it now here. Yes. Any questions? Okay, so moving on to part B, why is it important to randomize the type of shoe? Well, this really has to deal with confounding variables. And I think it's important to mention one in context. So could somebody think about a possible confounding variable in context of this situation that we could mention as part of 2B? Not seeing anything in the chat so far. Oh, we've got one now. Excellent. So we've got maybe some volunteers or professional faster runners while others aren't. Right. Yes, it's much of the same thing as before. It's the same issue of either previous training, experience, number of years as a runner, something like that. Exactly. Okay. So the first thing you want to mention is reducing the effect of confounding variables. You don't want to say anything about that variation, because that's not quite correct. Remember, it's the blocking really that goes with the variation, and the randomization really reduces the effect of confounding variables. So we can start with that. So randomization reduces the effect of confounding variables. And then you can actually say what that is. So you could say something like previous training, as an example. You could do stamina or something. I mean, you could even get creative and do something like, lung capacity, stamina, who knows what, okay, something like that. As long as it makes sense, that's fine, okay? But there's our real life context there, okay? So now we need to explain what that would do, right? So this confounding variable, the previous training, it would be associated with the response variable, the runtime, and then it would confuse the researchers, right? So I'll put that down. So that would be mistakenly associated with runtime if shoe type makes a difference. So it's very similar to part A. You know, the problem is the researchers would have a hard time distinguishing, okay, what's making a difference? So now we want to go into a little bit of a scenario to show the graders we know what we're doing. So let's just make an assumption, okay? So why are we randomizing the shoe and not letting them pick? Okay, so if runners select their own shoe type, let's think about what could happen. So if they select their own shoe type, it may be that the professional runners for some reason are drawn toward the more professional looking shoe or a different color of shoe or a different style or something. So, you know, we're not going to assume what these shoes are or what they look like. We don't have to come up with a description. But what we're going to talk about here is those who select shoe A may differ in some way than those who select shoe B. And you can literally say it like that, okay? So if runners select their own shoe type, let's see, we could just say those who select shoe A may differ in some way compared to those who select shoe B. And of course, that difference is going to make it difficult for the researchers to determine, okay, what is the effect here? Is the effect the shoe type, or is the effect really just this difference of runners self-selecting, okay? And you can say that, okay? So the researchers would then have a hard time seeing which comparison should be made, okay? So you can say something like the randomization allows researchers to make a better comparison of the variation that occurs from only shoe type, okay? Meaning shoe type really was the fact that made the difference, not the runner self-selecting. Because remember, there may be a hunch or some bias or some suspicion of, okay, the professional runners are going to go with the ones that look, you know, sleek red color or something. And then the ones that are a darker color, maybe the recreational runners prefer something like that. We're not sure. So the randomization helps to kind of even out that playing field. Any questions on B? Oh yeah, what would make the free response question a P? That's an excellent question. Well, lots of things. So if you started speaking about wrong information, like it would eliminate bias or something, that would be a little bit wrong. It doesn't eliminate any bias. There's no bias necessarily going on here. So if you said it would eliminate bias, but then you started talking about all of this, then that would be a P because your first sentence was wrong, but the rest was okay. Another way to make it a P would be to forget context. So you just forget maybe that second sentence about here. If runners select their own shoe type, what would happen, right? If I didn't mention that scenario in context of what would happen in the other situation, that would be a P because you just have a one-sided argument there. Another example would be misusing statistical language. So maybe you don't even know what randomization is and you confuse that with replication, or you start drafting a simple random sample of saying label subjects 1 through 100. Now that may even be an I because that's not even answering the question at that point. Another thing I think a lot of students would want to do with B is almost do a rewrite of A. And that makes this very difficult, you know, and that's why I picked this free response question. This is not an easy one. So I think a lot of you guys are looking at it like, wow, this is not too bad. Well, you know, it's not too bad when I'm doing it here, but if you had to do this blank, you've really got to think deeply about the difference between A and B. And I think a lot of students are going to get a P on either A or B because they really write the same thing without even knowing it. They kind of mesh them together. And that's a problem. So again, the big distinction here is the first one is on blocking, and blocking really is for that variability. And then for B, the randomization addresses the confounding variables. So if you're having trouble recalling that, please thoroughly go through the stats medic, maybe even relook at some of those notes in PowerPoints. This was the first chapter of the whole year. So this is way, way, way back there. Yeah. Any other questions? It's very important to be thorough on these. That's my best advice, and always attack it from both sides. That's my best advice. So answer the question and then go from the other side of it and say what would happen if the researchers didn't do it. So what happens if the researchers do it, and what happens if the researchers don't do it? And then you'll be sure to cover all your bases. Okay, so believe it or not, there's a part C on the back here, but this one's not as bad. It's at least very unique. Explain how the design of the experiment will address replication. And what is the benefit of replication? Okay, so first off, who can tell me how does this experiment address replication? Okay, and I'll flip back in case you need it. So how would this address replication? Who knows? Excellent. Multiple runners, sample of 50, anything like that. Correct. 50 in each group. Okay. So replication is seen because many runners, namely 50, wear each shoe type. Okay, half the question answered right there. No need to fluff it up. That's it. Done. Okay, now our next one, what's the benefit? So does anybody know the benefit of replication within the same block here? And here's another hint about the AP exam questions. You know, they have a very limited number of questions to assess your knowledge of a whole year of material. So if you think part C is also going to really be asking about a confounding variable, it's probably not, because you've already addressed that. So it's got to be something slightly different than what we've already talked about. Anybody know? This is kind of a hard one. It has something to do with variation. So does anybody remember sampling variability? It was a special type of variation, and it didn't mean you were doing a bad thing. It's just when you have different people, even if they're all professional runners, there's going to be some natural variation going on in that group as it is, because they're just humans, right? So it helps to account for the natural variation. So this helps to account for natural variation within each group, okay? And why is this important? Because you always want to go back to what question does this help the researchers to answer? So this allows researchers to make a better comparison of the variation that occurs from each, shoe type. We can put it like that. So what I've done here is I've got my context. So my context here is natural variation, each group, and then we have a better comparison. So I've addressed why is it important for the researchers, I've addressed context, and I've tried concisely to address both parts of the question. So explain how it addresses replication, that's the 50 runners, and then what is the benefit? Benefit is allowing researchers to make that better comparison. Because remember, there's natural variation within each group. So by replicating many, many subjects in each group, now the researchers know, okay, this is just occurring naturally in this group. It has nothing to do with the shoe type. So it almost gives them a baseline comparison. Does anybody have a question on part C? So my best advice for these questions is really try to do them without the scoring guidelines or any answers up, because I think they're a little bit more challenging than you think. Again, when I'm writing down the answers, you're nodding along, and, oh yeah, this is not bad. Oh yeah, that makes a lot of sense. Not bad, easy. But when you're handed it blank, it's a little tricky. So be sure on Stats Medic, you're working them out blank first and then make corrections as needed. All right, final call for any questions on this. This honestly, I believe, is the hardest one of them all. Okay, so moving on to the next one. This is from last year, 2019. I think this one is a lot more just self-explanatory. So I'll give everybody a second to read that. Okay, who thinks they can identify the treatments? Yes, all the concentrations, very good. Yep, and you'd want to list them out. So don't forget to do it with units. So they do ml/L like that. And you can just make a list, okay? There's no need to start explaining or anything. All right, so those are the 4 treatments. And experimental units. Any ideas on that? Yes, the insects. Now, we do need to be a little bit more specific. So actually, if you just put insects, I believe they would mark that as incorrect, because you are not spraying each individual insect with the mixture, according to this. because it says right here, the group of insects in each container, because it's too tedious to spray each individual insect. So can someone slightly revise that for experimental units here? And here's another hint. It's the experimental units are what you're labeling. You know, when we say label 1 through 100, are you labeling all of the insects? Are you tagging each insect? I don't think so, right? Yeah, we're getting better here. Groups of insects, insects in the 20 individual containers, containers. Yes, it's coming along, it's coming along. So you're gonna label the containers. You're not going to label the insects. So the best answer is the containers, okay? The 20 containers, and then if you have to mention the insects, if you just have to, which I understand why you're doing that, okay, then you could say each containing insects. That way it's guaranteed you'll get it correct. That's fine. Okay, and then response variable. Okay, excellent. Yes, we've got some good ones here. So, right, effectiveness of each fungus, and that is measured with what? Nice, Dana's got it. Nicely done. Number of insects alive, very good. Yeah, so number of insects alive. Okay, so that question's much more straightforward than the other one. Nice. All right, does the experiment have a control group? All right, so what do you guys think? Let's answer yes or no, and then who can identify the control? Again, this one is not meant to be too difficult here. Yes, good. Yep, and we've got it, the 0, correct, okay? So that's a yes, 0 milliliter per liter, and I swear to you, I mean, that is an answer. Okay, that is an answer. Now, if I was a student writing that on the AP exam, I'd be sweating with nerves. I wouldn't think that's enough to cover myself, okay? So what I would do just to make sure is I would do something like no fungus mixture given. There we go, done. Okay, now I'm guaranteeing myself credit, right? Got everything. That's it for B, full credit, it's an E. Now, C is the lengthy one. Describe how the treatments can be randomly assigned, okay? And this is where if you mislabel the experimental units, like let's say you label that as each insect and just assume the total number or something, you could still get an E on part C. You would just be docked credit for 2A, so just be careful. All right, who can at least start out C? So I'm not expecting anybody to type all this out in the chat box, but can somebody at least get us started? How did we always start these in class when we're trying to describe how treatments can be randomly assigned? There you go, label. Yep, very good. Label containers 1 through 20. That is your start, okay? So label containers 1 through 20. Okay, now you have to figure out if you're mixing them up in the clothes dryer, if you're doing paper slips in a hat of equal size, if you're doing technology, okay? Oh, yeah, and it looks like someone typed the 0 one. So yeah, you can do 0, 1 as well, but remember that's only if you're doing the random digits table, okay? And I don't recommend anybody do that. I really don't, because it's long, it's tedious, there's a lot of loopholes. I just don't recommend it. So I would say technology is the best. I think a lot of you like that way. So I'll just go with that one, okay? So use technology to select 5. Now we want to say, right, unique, right, because we don't have those repeats, okay, unique numbers. And just to cover our bases, we could even re-emphasize again, no repeats. Okay, just to be kind of OCD about it, we've got it in there, right? We're covered, okay, no repeats. Now, remember, you always have to link that to the treatment group, okay? So 5 unique numbers and spray these containers with, well, we could say the 0 milliliter treatment, meaning spray with nothing, right? And then you keep going, okay? So then select 5 other distinct numbers and spray with, and then you could say 1.25, right? Now, if you've given a couple examples, it is okay at that point to say, repeat this process, okay? So repeat this process until all 20 containers are sprayed. Now, how did I get the number 5? Well, there's 4 treatments, right? 1, 2, 3, 4. So I did 20 divided by 4. Now, the AP exam is not meant to be mean and nasty here, so usually they don't give you a decimal. But if it didn't work out, then you're just going to have to do your best with an odd number. So, you know, let's say it was 21 over 4. Well, you're still going to say, okay, I'm going to do 5, 5, 5, and then, you know, have 1, 6 or something. But do your best to make them equal. And then that's it. You don't have to talk about comparison because it says describe how treatments are assigned. That's it. It does not say describe an experiment. So if you keep talking about, okay, now we're going to collect the data, you know, analyze in a histogram or, you know, anything like that, you're just wasting time. So be sure you read the question. It doesn't say design an experiment, right? Just the treatment groups. That's it. We're done. Any questions on that? And this is from last year. And if this came up on the test, I mean, I honestly would be excited because this one is one we've talked about definitely a lot, in my opinion. So hopefully everybody's feeling pretty good on that one. Final call and questions? Okay, so our last one comes from 2018. It was actually the first question on the test here. A nice linear regression, okay? So I'll give everybody a second to read this. I love this too because it's about checkout lines at the store. Kind of relatable to the current times. Okay, so I'll sum up the situation. Basically, it's a comparison about how many people are in front of you in a line at the grocery store and how long it takes to check out. So not only the speed of the cashier, but you know how slowly the line is moving. So Obviously, if there's more people in front of you, overall, it's going to take more time to check out, okay? So it's been a while since we've seen this, but this is the computer output. So I just wanted to go through these components briefly here. Does anybody remember what this key number here represents? This 72.95 right next to the word constant. Yes, nicely done. Y-intercept. And then who remembers what this is? The 174.4. Good. Slope. Yep. Then you can get your equation, which is nice. Now, they cut chapter 12 from the course and the AP exam. We were actually going to talk about what all of this other stuff meant. So because of that, I'm not sure if they're going to put this box on the AP exam anymore. I'm not sure. You know, in previous years they have, because chapter 12, which again was cut and is not going to be on the AP exam, was where we talked about all of this. So if it happens to be on the AP exam, you ignore all of that, okay, because they have not covered what that means. That's chapter 12 stuff, so forget about that. And we never talk about the adjusted R-squared value ever. That's beyond the scope of the course. All right, who remembers what the S is? Yes, it is. Standard deviation, but standard deviation of what? Does anybody recall? Yeah. The data points, least squares regression line. Yeah, we're getting close. It's of the residuals, okay? The residuals. So this is standard deviation of residuals. Now, what is a residual? Well, just a reminder, residual. Okay, how we remember that? Remember A minus P, right? Actual values minus predicted. So what is actual? Okay, well, the actual are these actual data points, right? That's these points. And then the predicted is what is here. So which one has a high residual? I would say this one has a high residual because, well, it's really far away from predicted. What is a low residual? This one's kind of low because, well, it's actually on the line, right? It's kind of a residual of 0, really. So that's the idea on that. Okay, a little run through of regression. Don't forget, we do start always with a y hat when we're writing the equation, okay? And you have to say something like we predict or about. You've got to be very, very fluid in your English here. You can't say we will or there are, okay? So we predict and then ... okay? That'll give you credit right there. The other thing is you've got to define your parameters. So remember, if you're doing y hat, you have to say in the free response, let y equal blank and whatever it is. You know, here it would be time. You've got to define it. And don't forget, you know, let x equal blank. So just a couple of key reminders from the unit. It wasn't too bad of a unit, but a lot of you still forgot to define parameters there. All right, so let's go ahead and start it. So identify and interpret in context the estimate of the intercept. Okay, well, we already identified it. Okay, the intercept is 72.95 from the table. Can anybody type out what this means? Excellent. That is perfect. Very good. So if there were 0 customers in line, it would take around 72.95 seconds to check out. And yes, because it says around or predict, that is perfect. Yep. So I can rewrite that quickly for everybody to see, but that is perfect here, okay? So we predict the average checkout time to be about 72.95 seconds. If there are 0 customers in line. Yep, that works great. Excellent. Okay, for B, identify and interpret R squared. Yes. Okay. So the R squared value, 73.33%. Does anybody recall how we interpret R squared? Yes, nice. Must have had that response already ready to go. Excellent. So 73.33% of the variation in time, good, which is our Y, our response variable, is accounted for by the least squares regression line. Excellent. Yep. So, yep, we can say 73.33% of the variation in time. And remember, it's always time, which is Y, because that's your output of the least squares regression line. And then is accounted for by the least squares regression line. Yep, that works very well. Now, who remembers what you would do if it asked you to solve for R? Right, square root. Now, does anybody remember something special that we have to keep in mind when we take the square root of an R squared value? Yes, very good. Because yes, okay, good. When you take the square root of something, it can either be positive or negative. So you have to look at the slope, which in this case would be positive, and then you just get the positive value. That is correct. Good. Yep. So just keep that in mind. All right, so the last part, C, one of the data points was determined to be an outlier. Circle the point and explain why it's an outlier, okay? So on this exam, I mean, I don't think they're going to have you circle, because remember, some people are just going to be typing this in on a phone. Not everybody's going to choose to do it on paper. So I think circling for this exam is out, okay? Now, explaining why is not out. So, okay, what's the outlier? Well, I mean, hopefully you could determine that before you even took the class, right? So this one with the huge residual down here is kind of the outcast, so it's certainly this one, okay? And now we've got to explain what makes it an outlier. So, I mean, this is not as hard as it seems. It's because, you know, the Y value is so much different from what we expect. So let me do this on the back here because I'm running out of room. So this will be for part C, okay? So what was that point? It was about 3 and then maybe 50-ish, 350-ish, okay? So I'll just put that down for reference here. That was our point, okay? All right, so what you can say here is the X and Y value of this point differ from, and you could say the trend or pattern there we go, okay? And then you could even say something, you know, in context, which is always good because right now we don't have any context. You could say the checkout time for having 3 customers in line is much, well, it's either lower or higher, and here it's much lower. So it's much lower than expected. And that would be fine. You've got your context and you've answered the question. Remember, you don't have to identify the point exactly because, well, you don't have the means to do it. I mean, it's not exact here. And remember, guys, even if you plug it into the regression equation is going to give you this point up here, not this one. So you're just going to have to use your best estimate if you want to talk about that. But it's not asking you to do that. It's just asking you to explain why it's an outlier. Does anybody have any questions on this regression question? Yeah, go back to C. Let me just stop.